All right, we're going to talk about net ionic equations. So a net ionic equation is a reaction that shows the ions involved in creating a precipitate. So we're going to use net ionic equations for double replacement reactions only. Net ionic equations can be used for other types of reactions, but for the purposes of our class, it's just going to be double replacement. So go ahead and pause the video and write down these steps, and then I'm going to explain how these steps work with some example problems. Alright, so let's go ahead and break it down step by step, working through a practice problem so that the steps make sense to you. So number 1 says determine the precipitate of a double replacement reaction. Remember, the precipitate is a product of our double replacement reaction, and it could either be a solid or a liquid. Now liquid, remember, is just water, and then we can use our solubility rules to figure out if the product is aqueous or solid. So, in order to do that, we first need to know what our products are. So we'd have to predict our products for a double replacement reaction. So my two cations are going to switch spots in a double replacement reaction. So sodium is now going to be paired up with nitrate, and barium is now going to be paired up with phosphate. Now I have to check my charges because I formed two new compounds. So using my periodic table, I can figure out that sodium has a +1 charge and nitrate has a -1 charge. So we crisscross them down, but that's already neutral, so I don't need any additional subscripts. Again, using my periodic table, I can figure out that barium has a +2 charge, phosphate has a -3 charge, so I can crisscross it down, say Ba3PO42. Now, because this is a chemical reaction, I am going to balance it. So I have 1 barium here, but 3 bariums here, so I'm going to put a 3 out in front of barium nitrate. Now I have 6 nitrates on my reactant side, so I have to put a 6 out in front of NaNO3. And that's going to give me 6 sodiums here, but only 3 on my reactant side, so I need a 2 out in front of sodium phosphate. And now I have 2 phosphates, so I'm good to go. So next up, I have to figure out which one of my products are, or is my precipitate, right? Because that was step 1, determine the precipitate. So I'm going to use my solubility rules to do that. So I first look up nitrate. Remember, we always look up our anion. So it says all nitrates, acetates, ammonium, and group 1 salts are soluble. So there's no exceptions to that rule. So it's AQ. Next, I'm going to look up PO4, which is phosphate. And that's in the first bullet on the right-hand side. It says all carbonates and phosphates except group 1 and ammonium. They're usually insoluble. So because phosphate is not paired up with group 1 or ammonium, because barium is in group 2, we can say that this is in fact our solid. Okay, so we did our first part, determine the precipitate. Then it says the precipitate becomes the only product for the net ionic equation. This is where we start our new reaction. Alright, so this right here is my precipitate. So it tells me that that is the product of my new reaction. So my product is on the right-hand side. So there we go. Next step. It says the reactants are the ions that make up the product. Remember, ions have charges. So all reactants need a symbol, a charge, and an aqueous symbol because ions are dissolved in liquid water. Okay, so barium phosphate is made up of barium and phosphate. Then it says, so we have our symbol, now we need charges. Well, we figured out up here the charge of each of our ions, right? Barium has a +2 charge, phosphate has a -3 charge. Then it says that they have to be labeled AQ. So, AQ, AQ. And then our last step is to balance our new reaction. So I have 1 barium on my reactant side, but I have 3 on my product side. So I'm going to put a 3 out in front of barium. I have 1 phosphate over here but I have 2 over here, so I put a 2 out in front of PO4. So basically what this is saying is it takes 3 barium ions and 2 phosphate ions in order to form our product. Let's do another one. Again, let's follow the steps. So our first step is to determine the precipitate of a double replacement reaction. So I have to do the double replacement reaction. I'm going to switch hydrogen and sodium. So sodium is now going to be paired up with Cl, and H is now going to be paired up with OH. Now I need to determine my solubilities. Remember, HOH is the same thing as water. So we always put liquid next to water. Now, here I have a chloride. So I look up chlorides, and it says all chlorides, bromides, and iodides are soluble except when paired with silver, lead, and mercury. Well, we don't have any of those exceptions here, so we have aqueous. All right, this reaction is already balanced because we have 1 hydrogen, 1 hydrogen, 1 chlorine, 1 chlorine, 1 sodium, 1 sodium, 1 hydroxide, 1 hydroxide. Everything had a positive 1 and a negative 1 charge, right? Sodium's in group 1, chlorine's in group 7, which is a negative 1, hydrogen's in group 1, so it's a plus 1, and then hydroxide we can look up on our list of polyatomic ions, so that's negative 1. So it says we have to figure out which ones are precipitate, and aqueous we know is soluble, so that's not our precipitate, but the liquid water is going to be our precipitate. So then it says the precipitate becomes the only product for the net ionic equation. So, HOH. Then we have to write out our reactants. So the reactants are the ions that make up the product. Well, hydrogen and hydroxide are the 2 things that make up water. Now, they're ions, so we need charges and states of matter. So hydrogen has a plus 1 charge, hydroxide has a negative 1 charge. Because they're ions, we always say that they're aqueous. And then our last step is to balance. Well, I have 1 hydrogen here, 1 hydrogen here, I have 1 hydroxide here, 1 hydroxide here, so we're balanced, we're good to go. So this is how you write net ionic equations.